Welcome to part 2 of our tutorial to build a sample mash device. In the last session, we built a groove object, a waveform and a buffer, and we began to configure them. In this session, we'll finish that job and be able to pass some audio. So let's get started. Let's wire up the info box. So we're going to configure this to actually be connected to the second outlet of the buffer object. And that way, once the sample is loaded, the information has been successfully pulled into the info object and we should be able to see the maximum sample length. Let's take the outlet of our flow number box and we're going to configure this to be routed into the inlet of the end millisecond box. So when the sample has been loaded, the value will be populated through the cabling and appear in the end millisecond box. So we'll display the duration in milliseconds of the whole sample. To make sure that value actually works effectively, we should really cable up as well the second outlet of the buffer object into the inlet of the float. Due to Max's right to left priority, when the sample is loaded into the info box, the duration in milliseconds is populated into the number box. Then an additional message will fire out, bang, down into the cable to push the number from the flow num box into the number box that represents the final duration in milliseconds. So this is due to the right to left priority in Max. The first action will be the info box producing and pulling the data. That's then going to populate the flow number box, and then we'll be pushing via a bang message the data through into the end millisecond box. And this happens really quickly. This is happening at the speed your CPU can operate at. So that's the priority of the loading here for the scheduling. We're scheduling different data to happen by using Max's right to left priority. You see, this object's going to happen first and this one's going to be fired off second. Let's take the outlet of the select all button, and when the user clicks that, we want to be able to instantly also update the duration endpoint in milliseconds. So let's configure that into the input of the flow num box. So here's another operation for you. When the user clicks the select all button, we're going to be selecting everything in the waveform, but we're going to be once again reflushing the maximum duration of the end millisecond. So this is good practice to ensure that the waveform display shows all of the waveform and the region length is also the same value of the entire waveform. So we're nearly there. That's most of the waveform object configured, most of the buffer object configured. We can do a bit more fun and games with the groove object. So let's select the groove object and open the help. And we'll see inside the help menu, the groove object has got a whole bunch of different functions. One of the useful ones is to turn loop on and off. So we can see here using the message box with the value loop space 1 configures looping on the groove object. This allows the audio file just to cycle round. So let's make one of those. We're going to close down the help view, come back to our patch, and let's press M for message. Let's type in loop. But as opposed to typing in 1, let's type in $1. $1 is going to give us what we call a dynamic variable. So a dynamic variable allows you to replace the $1 with a value coming in from another control. So let's make a new object right above the loop message, N for new. Let's type in live.text. This is a graphical interface object, and we'll see here from the Max for Life family, it's a toggle button, and this particular button we're going to use to switch on and off the loop functionality. So let's connect its first outlet into the first inlet of the loop message. We're then going to send the loop message output into the first inlet of the groove. So the groove object receives most of its messages in its first inlet, and the messages allow you to configure its functionality. Let's select the live.text object and visit the inspector. And inside the inspector, we're going to make sure we can view the all parameters button, and let's scroll down. We want the live text object to operate as a toggle. So when it's clicked, it toggles on. When it's clicked again, it toggles off. But let's actually give some labels to it now. We can see inside here we have a couple of parameters we can configure to change the label and the text inside the object. So let's double click on this first parameter here, automation off label. Let's type in off. Let's double click on the parameter underneath it, automation on label. Let's type in on. And this will show up inside our automation lanes. Let's double click on the text off label. We'll call it loop. And we can actually put the same value into the text on B. We're not going to change the text within the actual object. When it's clicked on, it's just going to say loop in both states. Let's lock our patch with the padlock in the bottom left-hand corner. If we click on the loop button, we see it goes yellow. It's activated. Click on it again, it's deactivated. Let's unlock the patch. And let's see how this works. Let's make a new message box. Press M for message. And let's connect the output of the loop $1 object into the right-hand side, the second inlet of the message box. So what will happen here is when we click the loop button, we'll be pushing and firing the loop value with a dynamic variable into this message, and this message will display it. We've used the right-hand inlet, which is the option to allow you to display the message. Let's lock the patch so we can integrate with it as a user, and let's click loop. And we can see when the loop is on, we see loop 1. When it's off, we see loop 0. So this is a quick introduction to using dynamic variables that can be driven from graphical user interface objects. When the loop button is on, it's transmitting a 1. When it's off, it's transmitting a 0. And we use the dynamic variable $1 to pull that value in and to append to the end of the message, so the final output is loop 0 or loop 1. This is the structure of the message the Groove object needs to configure its loop function. Okay, we could actually delete that new message box because it's just there to demonstrate a concept for you. So let's unlock the patch and come back, select it and delete it. Now it's good practice when you're using Max for Live and Max to maybe label some of your objects a bit more clearly. Let's select our loop object and visit the inspector. And we can see about halfway down the inspector, there is a section which is probably arguably some of the most important bits, the parameter section. And we've also got here a scripting name. So there are 3 names we can label for every object in Max. We have a long name, a short name, and a scripting name. So it's good practice to label each of these different names with similar values. This will help you to avoid getting in a bit of a mess later. So in the scripting name, let's double click and type loop. And then let's activate the link to scripting box. And we'll see the value in the scripting name has been pulled down to the long name. Let's double click on the long name and copy the text into the short name. We have now got the same name in all 3 of our values here. So the long name is the name that will show up inside Live's automation lanes. The short name is the name that will be displayed in the interface for elements like the rollover help and the info view in Live. And the scripting name is used for scripting functionality for the object. For example, if you want to hide and show different parameters when a user clicks a button. We're not really going to be doing any scripting in this tutorial, but it's really good practice to get a handle on labeling your different objects suitably. So I do recommend to use the same values in your scripting, long and short names. This way things will show up successfully for you in the automation in Live. We should really be taking the same practice for our other graphical user interface elements. So here I've selected the live.num box, which represents the start milliseconds parameter of our patch. Let's scroll down the inspector, and again inside the scripting name, let's type in start. You can maybe use an underscore if you want to put in some spacing. You can't use a space. Max will not let you. Maybe you could use camel case like this, or potentially if you want to, underscores are quite helpful. So don't forget to activate the link to scripting name box, and let's copy and paste down our start milliseconds into our short name box. Each object in Max has a section of parameters that need to be configured successfully. This particular object is using floating point, so it's a decimal place number box. However, you can see its range is only going from 0 to 127. So at the moment, this is configured incorrectly. We'll only be able to take the sample from 0 milliseconds to 127 milliseconds. We need to extend the range. Now, we don't really know how long the sample would be that a user would load in. Maybe a quick workaround for that is to actually configure the range to go from 0 to some arbitrary big number. This value here represents the maximum number the live number box can use. So for example, if we lock the patch and manipulate the number box, we can see we can only go up to 127. So to provide proper functionality for selecting the start and end points of the sample, we do need to configure the range of both these boxes. Let's move the second half here to a ridiculously big number, just to make sure we've got some headroom and we can actually then push up this value in the interface if you need to. Let's unlock the patch, select the end millisecond box, come back down to our parameter section. Let's label our scripting name. So this could be end_milliseconds. Don't forget to link to scripting name and to copy and paste over your end millisecond text into the short name box. And once again, we should push up the range to give us a little bit of headroom. So our algorithm later that uses the random number generators has got a lot of headroom to reach. If this number is not high enough, we'll be constraining the endpoint of the sample playback. So we need to give it a little bit of headroom by typing in some ridiculously long number. Okay, so that's most of the waveform object completed. We've obviously got other options we can do. We could maybe grab the waveform object, and if you scroll down, you can see you can actually maybe choose different colors. Let's click onto the background color swatch. Quick tip for you here, if you click onto the color wheel, you should be opening some of the color swatches for your system. You've got various different presets in here. On Windows, this will look slightly different, but we could, for example, choose color that's suitable. So multiple ways to configure the colors inside Max for Live and Max on Windows and PC. But you see here I'm just using a simple crayon for my color swatch to give me maybe a different background. Maybe we should make the waveform dark. So having a light coloured waveform on a light coloured background probably not going to help very much. Let's click the waveform colour and let's maybe choose a dark crayon to be able to make sure we've got a suitable waveform display. So far we've managed to generate a groove object labelled sample mash. We've created a buffer object called sample mash, and we have an info object called sample mash. They're all referring to the same argument, or in other words, they're all referring to the same section of RAM. So we need to do this for the waveform display. So let's right click and open the help of the waveform. Now the help provides lots of different information through multiple tabs, but the help really is sort of the introductory section for help. There is a much more comprehensive page. If we click onto the question mark, we can open the reference. Now the reference provides a much more detailed set of information about how this object is constructed and what you can do with it. So the help's good to get started, but sometimes you might need to dive into the reference object to find out a little bit more about the object in question. So this actually loads up some of the documentation in Max from the help. And we can see here, if we scroll down, we've got information about all the attributes for this object. If we keep coming down, we can see we can configure grid colors, we can set up offsets, we can do all sorts of crazy stuff. So the reference really is a much more comprehensive overview of all the different types of functionality that the object in question can do. If we scroll down to the bottom, we'll eventually see we have different types of message the object will respond to. So we saw an example earlier of the groove object responding to the message loop 1 or loop 0. And the waveform object also has its own bunch of messages. So let's come down a bit closer. We can see right down the bottom, we've got all sorts of different parameters here. You can even normalize the audio inside the buffer. You could replace the contents. The one we're looking for here is the message set. So the word set, followed by a symbol or int, which is the name of a buffer object, links the waveform to the target buffer. So this is super important. We need to set our waveform to use sample mash. And we'll be doing that by using the message set. Let's close down the reference and close down the help. So let's make a new message box, M for message. Let's type in set. Make sure you leave a space and type in sample mash. And again, be careful with your spelling and typos. It's got to be correct. It's case sensitive. Let's take the outlet of the set message and we'll plug it into the first inlet This is the first inlet, which is really where all the messages are plugged into that the waveform object will respond to. So we want the set message to be able to be configured when the user first loads the device. So we can do this really easily in Max for Live. Let's press N for new. And we're going to make an object called live.thisDevice. And what this does, it sends a bang when a device has been loaded inside Live in the device view. In other words, it transmits a on message, or a 1, or a true, or a bang out, which we can use to fire off different elements within our patch to configure things when they're first loaded. Let's take the first outlet of the live.thisDevice object and wire it into the inlet of the set. When the user loads the device, live.thisDevice fires a bang message to trigger this message. This message is therefore pumped into the waveform object, and it has its successful configuration to speak to the buffer object and to speak to the groove object. Okay, so these two objects here really represent a way to configure the status of an object when the device is first loaded. It's sort of initializing the object for successful use back into Live later. So the next thing we're going to do here is we're going to mess about with getting some stuff working with the groove object. So let's close down the inspector, get a bit more screen real estate. We'll come down to the groove object, and I'm going to move my loop button a little bit out of the way just to sort of get this a little bit more tidy, to give me a little bit more space on the screen. We do need to add loop to presentation mode to present it to the user in the interface, and enter presentation mode, and we can now configure and position your loop button wherever you like in your interface. Let's go back to patching mode by exiting presentation. And we're now going to build some controls to fire the sample off, to trigger the sample. So let's select the groove object and we'll right click and look inside the help. And we can see the groove object is configured by firing a number into an object called sig, and that's an audio object working in the MSP domain. And that fires over an audio signal into the left input of the groove. And this is the speed of the playback. When we fire in the number 1, that is converted from an integer into an audio signal via the sig object. The sig object's role is to convert data from the max domain into the MSP domain. It's really a conversion tool to convert the value into an audio rate signal. And that audio rate signal is used to fire the groove object. So by using different values in the message boxes, we can control the playback speed of our groove. So if we were to send in -1, we'll be going backwards at normal speed, 1 forwards at normal speed, 2 double time, etc. So let's close down the help for groove. And back inside our patcher, let's press N for new to create a new object. And that object will be a sig object. We can see it has the tilde as it's an audio object, and it converts numbers into audio signals. So we're going to use this to drive the playback speed of the groove object. Let's wire the output of the sig object into the left inlet of the groove. Again, the left inlet of the groove object is where most of its major parameters and messages are sent to configure its use. So now we could make another little text box above the sig, because we want to be able to sort of display the playback speed to the user. So let's press N for new, and we'll type in live.numbox. We made one of these earlier. That numbox we're going to wire into the inlet of the sig. Let's add the numbox to presentation. And let's visit the inspector. And we can see, once again, we can follow the good practice about labeling up our different scripting long and short names. So let's type in speed in the scripting name parameter. Let's activate link to scripting name and then copy the value from speed from the long name into the short name. And, we can probably increase the range here if you like. However, playing over 127 times quicker than normal is probably all right in most circumstances. Let's add a comment so we can actually display what this control does to the user. C for comment. Let's type in speed. Sometimes you might need to tweak the size of your comment boxes. They often come in a bit long, and we can obviously configure this to be a little bit neater and add it to presentation. So back to presentation mode now. and we can add our speed parameters into the GUI. So I'm going to position this a little bit over to the right-hand side. Let's close down the inspector, come back into patching mode by leaving presentation, and let's save our patch. Our next little job is going to be able to fire in a number message into this box. So let's press M for message and type 1. This will provide our normal playback speed at the original pitch and tempo. Let's wire that into the input or inlet of our live.num box. Let's make a new object. We're going to type in N for new, live.text. This is a graphical interface button that has text. We made one earlier for the loop section. And let's pull that up and wire its outlet into the inlet of the message box. Let's make sure our new live.text object is selected and visit the inspector. And if we scroll down, we can actually maybe configure right at the very bottom down here, as we did before, the parameter names. So let's change text off label to normal. And we'll do the same for text on label. So it just displays the text in its on and off state. Let's adapt the automation off and on labels. And we'll just simply type in off. This will show up inside our lanes in the automation later. And type in on for the on parameter. So you can see here the little box now, all super duper. Probably a good idea to make sure we're using our standard technique for naming. So back up to the parameter sections and let's type in a name in the scripting name parameter. I'm going to type in normal and link to scripting name and copy and paste the long name into the short name. So once again, good practice just to keep a handle on the labels of your variables or your names of objects inside Max. So let's come down to the bottom of the section here and we can see we don't really want to operate this as a toggle. This is really going to be a button. What we want to happen is when the user clicks on it, it transmits out a 1 message. When they click on it again, it deactivates. So let's go to button mode. And you can see by going to button mode here, we've got the bang when transition from parameter. And there's a little rollover here we can point to for a bit more information. And we'll see when we click on it, it's going to go from a 0 to 1 state. It will be firing out a bang, which we'll be using then to fire the 1 value in the message box into the speed box. So again, this is all really about sort of operation of scheduling in Max to use bangs to trigger events. Let's make sure our normal button has been added to presentation mode. And let's come back to presentation mode again, and we can position that button wherever you like in your interface. It seems we need to also add our fader. Let's leave presentation mode, come back into building mode, and right-click on the live.gain slider to add that to presentation. We can then go back to presentation mode and configure that wherever you like in your interface. Let's save your patch, and if we close down the patcher here, we should return back into live and we can test it. Let's press the load button and load a sample into the buffer, and we can see instantly it calculates its maximum duration in milliseconds and populates our start and end boxes, and the entire waveform is selected. So now we should be able to just press the loop button and trigger it via the normal button. And if you play with your speed parameter, and the value is 0, stops the loop. So that's the end of part 2, guys, of the sample mash tutorial. Thanks for joining. In the next session, we're going to be adding the random number generator to produce some glitches. So I hope to see you there.